So it's recording right now. Just to let you know. So hopefully Mim's gonna get on. I don't know how else to help her. I sent it like 3 times now. Let's try one more time. Let's see. Okay. I don't know. Hopefully she'll be able to get on. Okay, so no, dang. Okay. Let's have her send Gmail. Send us the day Gmail. And then you just need to try her Gmail. So did you guys go over it today? The lesson.
Like the y-intercept stuff?
Yeah.
Yeah.
Okay, good. Because I don't know if I really understand it all, so I'm hoping that you guys will understand it.
I don't fully understand it, but I think we'll be okay.
We probably will. This one I got to do homework.
Quick look at it because I just got home about half an hour ago.
Okay. Let's I don't know. I guess I just gotta wait for her to ask me her other email address because this is obviously not working. All right. Given the number 3, given the linear regression equation, what is the y-intercept? Round to 1 decimal.
Isn't it? To find the y-intercept, don't we just plug in 0 for x? No?
Don't we just solve it? See, this is the part where I was like, what? If y, so if I have my little thing up here, and I have, well, let's say I go like this and slide that one over a little bit. I don't know where to put it in. I don't have a standard deviation. I don't have a model. I do have a y, right? I have a BO or BO. I have this. So we have, is this the point 2.0? And we have that, which is, or is, I don't know. Let's go 1 point. That didn't work. I don't know. What am I supposed to do with that?
What's the, I can't see the question.
Okay, so the question is, I'll pull this one over here briefly. So the question is, given the linear regression equation, y equals 2.0 plus 1.5x, what is the slope? So is it just asking, oh wait, that's number 4, so sorry, number 3. Given this equation, what is the y-intercept?
Then just send another.
Okay, let's try to type this one in.
Would the slope just be the 1.5?
That's what I'm wondering.
So does that make the number 3 2.0?
That's what I thought. Because like you would just plug in 0 for x, and then that would cancel out the 1.5, and then you're left with 2.
Yeah. So do you put 2 or 2.0, or does it matter?
I would put 2.0.
Let's do 2.0.
So 3 is 2.0 and 4 is 1.5.
Let's just go 1.5.
Okay.
And then So number 5. Okay, her thing's done. All right, so number 5, given the linear regression of y equals negative 3.0 and plus 0.25x, what is the predicted value of y when x equals 16? So this is where we got to do the math, right?
Yeah.
I got 1. That can't be right, is it?
Hold on.
That can't be right.
I got
Oh, yeah, I guess
0.
it is, because you got 4 minus 3 is 1. 1.0.
4.
So 0.25 times 16 is 4. You have 4
Oh,
and a
yeah.
negative 3.
Okay, yeah, it's 4.
Okay.
So yeah,
I could be
1.
doing it wrong, so I'm happy. Okay, make a scatter plot of the math efficient data of the 3 data shapes introduced in the reading. Which shape best describes the data? Okay, I will. Let me drop that one down and I will put this in. So oh, this is that long one. Okay, there's the scatter plot. Minus that one out.
Is that a hamburger? No. Yeah.
I don't know. I don't have my lesson thing open. What do you guys think?
The options are hamburger, banana, or hot dog.
Yeah.
I think it's hamburger.
Hold on, we'll go like this. Let's look at lesson 22. Okay, there you go. You see that? Hot dog?
The hot dog?
Hot dog.
Hot dog,
Okay.
okay. All right, man, sorry. I don't know why. I sent it and sent it and sent it. I don't even know why it wouldn't go.
Yeah.
Okay, so we just started kind of at the beginning.
Okay.
We're on number 3, we just the y-intercept, we just put 2.0. And then number 4, we just did 1.5. And then we calculated that out, substituting the x for 16, and we came up with the answer 1.
Okay.
And then we just plugged all this in and decided it's a hot dog shape.
Okay.
Okay, and so question 7, based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? I don't know, let's look at the lesson again. I can't remember my reading. It says, conduct a regression analysis, determine if there is, that yes, we can, right? Linear pattern. We can use simple regression to develop the equation relating to number. Okay, I think we can use it, right? Or let me look about simple linear regression model.
So the first one?
Yeah. Okay. Okay, 8. How many observations are in the data? What do they mean by that? Do they mean like there's 140, or I guess it's 140 minus. Oh, you know what? I better touch on that. Excel, sorry. Let's look at that. Where would that tell us? Maybe it doesn't. Okay, I don't see it. This starts at 2, so I'm like 139. How many observations are in the data? I don't know. Do you know what that means?
Mm-mm.
No.
Okay, I don't know either. I'm gonna look one more time at this website, or this T-score. There's T, there's P, there's confidence interval. Okay, well, I don't usually do the homework till after we do our group thing, so I don't know. All right, let's look back at here. I'm saying 139. I don't know what else, unless it wants like all of them, then 139 times 2. Could that be what it means? No, it couldn't be. Okay, I don't know. Okay, number 9. What is the y-intercept? So 2.0.
Yeah.
Yeah.
Okay, what is the slope round to 3 decimal places? Okay, so slope, like right there, the 1.5.
Do we keep it to 1.500?
Yeah.
Yeah. I feel like it doesn't, the decimal thing is weird.
I feel like sometimes even though it asks for it, it doesn't
doesn't
want it, and sometimes it does.
Yeah, and like, or it won't take points off if you just
Yeah.
Yeah.
What is the predicted value of y when x is 4? So it's kind of like that same equation we had earlier. So we're basically doing
What's the equation?
2 plus 1.5 times 4, right?
Yeah. So 8?
That's what I have, 8. Okay, 12. The confidence
Just 8?
interval. What?
Just 8?
Oh,
Is it
I
8
guess
or
this would be
8.0?
8.00. I don't know.
I'm just gonna put 8.0.
I'm just looking to see. Okay, I wonder. Never mind, I don't know. I don't know how to use this spreadsheet on this one. Speak up if I have got it wrong. The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? And because there is a positive correlation, we can use the largest x value to find the largest predicted value of y. So we're gonna, what is the maximum predicted value of y for these values? So basically we're just substituting that 4 into a 6. Is that what it's asking?
Okay.
So 11?
Yeah.
Hold on.
I have to write down that hint because positive. correlation. Use ridiculous number.
Okay.
Okay. Number 13. How many explanatory independent variables are presented in a simple linear regression?
1.
I'll go with min. 1.
Okay.
Or is it 2? How many explanatory?
I think
Just 1. No, that's just 1, right? Because that's the x-axis.
yeah.
How many response-dependent variables? There's just 1. The company in South Dakota manufactured hard hats used in the mining industry. They recorded measurements of all the hats they produced for quality control and planning purposes. The measurements they collected included hat size, circumference of the hat, the length of the major and minor axes, meaning the company wants to predict the size of hat given the circumference. What is the response to the variable? Predict the size. Okay, so the response is the size of the hat, right? Because that would be why we're trying to figure out the size based on the circumference.
Yeah. Size of the
Yeah.
hat because it's being used to predict the circumference. What was
Okay.
8? I missed 8. I mean,
Okay, size of the
7.
hat because it's being used to predict. Wait.
You don't think it's that one?
Yeah. Okay. Meaning, what is the reason? Yeah, it's the first one. Are you saying the first one or the third?
I said the third one. Is that wrong?
I think it's the first one.
I think it's the first one because the size of the hats are constant, and we're trying to figure out.
The variable.
The response is we're trying to figure out the size of the hat.
Okay.
That's what's
I think
trying to be projected. Okay. Here, let me save it. I'll go and submit it.
What was number 7?
Oh, number 7. We put the first one, linear regression is appropriate for these data.
That's what I thought. Okay, sweet.
And what's number 12? Is it 11?
So number 12, 11.
Yeah.
Okay. I'm going to go submit it, and I'll tell you how we did. Because then we got to figure out what to do with all our data for that. Oh, darn. Well, don't listen to me. So 9, 10, 11, 12. 9, 10, 11, 12, we don't know.
That's interesting.
Yeah. So, okay, let's relook at those. I'm just going to write down my answers on it. So at least we got those are a guess, 3 and 4. Okay, so we got 7 right. Okay, so number 9, we don't know. Number 10, we don't know. Number 11, we don't know. Number 12, we don't know. Okay, so we missed 4. We could each take one and try to find the answer to it.
Okay.
Which one did we miss again?
9, 10, 11, 12.
I can do.
I'll do 9.
I can do 11.
Okay,
I'll do 10.
okay, I'll do 12 then.
Okay. What is the problem.
Okay, cool.
So what was the equation that was given?
Okay, which one are you doing? 1 and 10?
I'm doing 10, yeah.
What is the slope? So it goes all the way back up here. So for the next 7 questions, use the data file map self-efficiency. Be sure to use the confidence data for the explanatory variable and score data as the response variable. So X and Y. Okay, scanner hot dog shape. So this is, I'm gonna upload it over here. Okay, so I'm gonna double check and make sure that there's our X, there's our Y. Let me double check on this now. So the score was supposed to be X, right?
Yeah, I think so.
Oh, score is supposed to be Y. Okay, let me switch it around. Apparently I need to read them better. My gosh.
I'm confused. Wait. Because I would have put 2.0.
Yeah, because I thought it doesn't matter which. Maybe it does. Ugh. Okay, let me read. My mouse is being stupid. Okay. Okay, so I think I have it in right. It still looks like 2.0, 1.5. Okay, let me look at the video. Interesting, okay.
Do you think it's maybe just 1.5 instead of 0.0?
I put 1. Oh, I didn't submit mine. Do you think it'd make a difference?
I know sometimes it has and sometimes it hasn't.
Okay, so if we have a problem, Let's look at this. It's in. I don't know. I don't know what it is. Why is it? If we look at this one up here. So we have Y and we have, and maybe it is. Maybe it's the zeros that are throwing it off.
Okay, so let's take off the zeros.
Okay.
So are we going to put 2.0 or just 2 for the y-intercept?
Well, didn't we put 2.0 before and it was wrong?
Let's put 2.000 because that's what the Excel said. So I have 2.00. What about if I did this? Let me start a fresh little page here. I'm on linear regression. Okay. Sometimes if I refresh it, sometimes it works better. I don't know why. I just have one of those lucky experiences. Okay, and we go to linear regression. And the score is supposed to be the Y. This class. I really thought I liked it in the beginning, but I really hate this class now. I thought it was going to be fun and interesting, and I was getting it, and now I'm just like, I'm done. I'm so done.
Yeah.
We're almost
Whole
done.
semester. This whole
I'm
semester.
glad it's almost done.
Okay, look, when I did that and did it again, it changed these numbers.
Okay.
So 18.690.
690. Sometimes I have to just shut it down and reopen it in the, so that's kind of weird. So 18.690.
And 12.695.
I just forgot already. I forgot my numbers. Okay, let's see. 18.690. Right? Why? I'm on the right one, right? 9. Okay. And 10. 12.695. Okay, so that brings us to 11. What is the predicted value of y when x equals 4?
I got 69.469.
So 69.469, like that?
Yeah.
Okay. The confidence data resulted from the students evaluating their confidence for each question on the scale of 1 to 6. What is the maximum predicted value? Well, it would probably make sense now that we have the correct answer. If we do 6 times all those numbers.
Man, did you say 69.469?
Yeah.
Okay, so 94.86.
No.
But I don't know if I calculated that right. So number 12. Does that sound right, Min?
I'm not sure about this.
Okay, so the confidence data results from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Because there's a positive correlation, we can use the largest x value to find the largest predicted y value. All right. I just plugged in 6, but it makes a huge difference when we have these other numbers that show up. Dun, dun, dun. These two, dramatic change. So maybe our method was right. We just didn't have the correct data from Excel. Okay. Anybody want to be brave and submit now?
I can do it.
Okay.
Wait, which one did I miss? Oh my goodness. Okay. Yeah, so it's all right. I got 8 wrong because it's 1.392, right?
No, just 139.
It's 139.
I put 1,392.
Yeah, that's a little big. But the rest were right?
Yeah, the rest are right.
Okay.
Okay, sweet.
Okay, good. Now we can take a few minutes really quick and talk about how we're gonna deal with this next page.
Okay.
Oh, darn, I still missed one. Oh, 9. I put it in backwards. Oh, well. Whatever. At this point, I don't care.
I know, me neither.
It's too late. Okay, so let's look at, get rid of this thing. And let's look. I have it down here. Okay, so I have this. So this is the make inference. Why is it and I'll pop it over to the Google Docs. But so we're gonna title this final project Make Inference Take Action. We'll put all our names in there. We state our research question, which is, is the price of bread different online depending on the location? So it's going to be a not equal to. The name of the hypothesis test you choose to use, which initially we said the independent t-score. Okay, 1 to 2 paragraphs discussing whether or not your data meets or fails to make the requirements for your hypothesis test. If you use the QEQ plot or box plot, include those in your documents with explanations. Also write out any formulas you are using to show that your data meets the requirements. State your null and alternative hypothesis, and then state these in symbols. State your alpha level. What do you want to do for alpha? Like just the standard 95% confident level?
Yeah.
Let's just do that. Give your test statistics and its value. State your p-value. Based on your p-value and your alpha level, state whether or not the null hypothesis would be rejected or failed. Okay, so I'm going to put this on the Google Docs. I'll let you guys. We need to pull it up anyway so that we can look at our data. Oops, I just did it twice. Okay. So here's on the Google Docs, and you guys should be able to open it up, I hope.
Okay.
Anybody do I have to share it? Doesn't look like it.
Are we just going to be answering these questions?
No, because, well, we're going to answer them, but we have to take our data. We need to do an independent test. So, like, we need to pull this thing up. Man, I'm not going to lie. I thought this was the one I thought this was what your your part was, because I just had faith that you would do it right and know what it was and what we were supposed to be doing.
For this one?
Do sample t-test, independent, right? So we're going to put all our breads in. And and we're going to put over here the early. And that's not a broadcast right now.